Section 6.3 is box and whisker plots. Our goal is to use statistics appropriate to the shape of the data distribution to compare center and spread of two or more different data sets. On page 392, we have in the Solvit, you may have looked at different parts of each dataset in order to compare the two datasets. Separating data into subsets is a useful way to summarize and compare datasets. Quartiles are values that divide a dataset into four equal parts. The median, or second quartile, Q2, separates the data into upper and lower halves. The first quartile, Q1, is the median of the lower half of the data. The third quartile, Q3, is the median of the upper half of the data. The interquartile range is the difference between the third and first quartiles. Here we have an example of a set of data organized from least to greatest. The first number will be the minimum, the last number will be the maximum, the middle number will be the median, and then we will exclude this 11 here, and then we will find the median of the lower half, which is Q1, and 5 in this case. And then again, we will exclude the median and find the median of the upper half, which would be 21 here for Q3. The interquartile range is Q3 minus Q1, so we would take 21 minus 5. For a set of data that has an odd number of values, you do not include the median in either half when finding the first and third quartiles. On the other hand, if we had an even number of data values, the median would exist in between the two middle data values. So we would include those two data values on either side. Example 1 says, what are the minimum first quartile, median, third quartile, and maximum of the data set below? We have 125, 80, 140, 135, 126, 140, 350, and 75. Our first step is to reorder the data from least to greatest. This will help us find our minimum and our maximum very easily. The minimum is 75, the maximum is 350. And now that we have our data in order, we can also find the median. So we can count one on each side. So we have 75 and 350, then 140 and 80, 125 and 140. And then in the middle, we have 126 and 135. We had an even number of data values, so we have two values in the middle. So to find the median, we will find the average or mean of these two values. This gives us 126 plus 135, or 261, divided by 2, which is 130.5. Now to find our first quartile, we'll look at just the lower half of the data. So the first four values, 75, 80, 125, and 126. Again, we can count in from the outside, so we have 75 and 126, and since we only have four values, the next two are actually the middle again. So our Q1, or the median of the lower half, will be 80 and 125's mean. So we have 80 plus 125, or 205, divided by 2 will give us 102.5 for the first quartile. We will do the same thing for the third quartile, except with the upper half. So we'll start with 135, 140, 140, and 350. Again, we only have four values, so counting in from the outside, we'll get rid of 135 and 350. We're left with 140 and 140. We want to find the mean of 140 and 140, which would be 140 plus 140, or 280, divided by 2, which gives us 140. If you end up with the same number in the middle twice, the mean, or the average, of the same number twice will just be that number. So you don't actually have to do these steps here. If you saw 140 and 140, you could just say that the third quartile would have been 140. The work for this problem is written out on the next two slides. And now I would like you to try homework number 2 on page 393. Find the minimum, first quartile, median, third quartile, and maximum of each data set.